Good morning to all of you. Today we will do the subject mechanics of solid. Last class I have done problems in symmetrical section, but today I will do bending stresses in unsymmetrical section. Clear? So in case of symmetrical section, the CG passes through the distance of extreme favor from the neutral axis is y is equal to d by 2. This is symmetrical section. This is d, this is y. What y is equal to? D by 2. Clear? This is also circle. The circle is a symmetry section. In this case also, this is D, this is neutral axis, this is also neutral axis. Y, what y is equal to? D by 2. Clear? So both are symmetric sections, but today I will do problems in unsymmetric section. Unsymmetric section means I section, P section, Z section, L section. Clear? So today our subject name is mechanics of solid. Mechanics of solid. The topic is bending stresses in beams, but today I'll do the problems bending stresses in unsymmetrical sections. Clear? Bending stresses in unsymmetrical section. Clear? This is symmetrical section. These both are symmetrical section because in both cases y is equal to d by 2. Clear? But this is T section, this is L section, clear? This is I section. Clear? In these cases, y is not equal to d by 2. First, we will find out y bar or yc. Clear? Suppose this is centered, this is neutral axis. This is also neutral axis. Suppose this passes through neutral axis. I already told you the neutral axis passes through the CG of the figure. Clear? So, suppose this is YC. First find out this is G. So this is G. So the neutral axis passes through center of the figure. Now, first find out the distance of YT and YC. YT means distance of extreme fibber from neutral axis on tension side. YC is equal to distance of extreme fibber from neutral axis on compression side. So find out both YC and YT. Take the bigger value of YC and YT as Y. Clear? Suppose this is YC. YT, this is YT. This is YC. So here also, suppose this is YC. this is yt. Here also suppose this is yc, this is yt. Clear? First find out y bar, then yc yt. Take the bigger value of yc and yt as y. What is the equation? The bending equation is sigma b by y is equal to e by r is equal to m by I. Clear? This is equation of bending. In this equation, the y, you require find a y, means the bigger value of yc and yt is equal to y. Clear? Now I will write some note regarding this theory, then I will do problems of I section and T section, L section. In case of in case of symmetrical section, symmetrical section, the distance of extreme favor from the neutral axis is y is equal to d by 2, d by 2. Clear? But this is not possible in case on symmetrical section. Clear? But it is not possible in case of on symmetry section. Clear? In case on symmetry section, in case of on symmetry section, first find out the position of CG. The position of CG. Clear? The neutral axis passes through CG. The neutral axis passes through CG. Passes through CG. Now, then find YC and YT. For both compression and tension side. tension side. Then take the bigger value of, then take the bigger value of YC and YT as Y, as a Y, and use in the equation, use in the bend stress equation, that is sigma by Y is equal to E by R is equal to M by I. Clear? To solve the problem, solve the problem. Clear? Now I'll do some problems. This is problem of 79. Problem of 79. This is question of 79. Very important question. I section on symmetrical beam. I on symmetrical section. The question is, a beam of an I section shown figure is subjected to a bending moment of 500 kgcm at its neutral axis. Find the maximum stress induced in the beam. Clear? Suppose this is section 1, section 2, section 3. Clear? First find out what is Y and what is I. Moderness about neutral axis and distance extreme fiber from the neutral axis. Clear? So first draw a table. Clear? Draw a table to find out I and Y. This is serial number section. Section 1. Area A, Y, AY square, IG, or IG self. Clear? Section 1. What is area? Suppose this is 1 on axis. So calculate all the values referring to this axis. Calculate all the values referring to this 1 on axis. This is section 1. What is the area of the section? 6 into 2. Same square. Area same square. 6 into 2 is equal to 12 same square. Y in same. y1. What is y? This is g1. This is y1. What is y1? 2 plus 10. So this is 1. 2 by 2 1. y1 is equal to 2 plus 10 plus 2 by 2. 13. Clear? Ay. What is ay? Same q. 156. Ay square. Same fourth. Ay into y. This is equal to 2028. Same fourth. Ig1 for 1 Ig1. What is Ig is equal to? Bt equal to 12. 6 into 2q by 12. Okay. 4 same fourth. Next, come to section 2. This section 2. This is G2. This is equal to G2. So what is Y2? This is Y2. This is G2. Clear? What is area? Area is equal to 10 into 2. 20 cm square. Y2, what is Y2? This was this. 2 plus 10 by 2, 5. 2 plus 10 by 2, 7 cm. Ay, cm q. Ay square. 140 into 7, 980. Cm fourth. Ig, what is ID? Ig 2. Bt equal to 12. 2 into 10q by 12. Clear? This is equal to 166.69. 67. 166.67 cm fourth. Right? This is section 2. Section 3. This is G3. This is Y3. G3 Y3. What is area? B into D. 10 into 2. Area is equal to 10 into 2. 20 cm square. Y. This is Y. What Y is equal to? 1. Ay 20. Ay square 20. Clear? Same fourth. Ig3. Bt equal 12. 10 into 2qi 12. Clear? 20 by 3. 6.667. Now 1 plus 2 plus 3 sigma A, or sigma is equal to 20 plus 20, 40 plus 12, 52 cm square. Sigma A 52 cm square. Sigma AY, sigma summation of A y 160 plus 156, 260 plus 56, 316. Same Q, same square A, sigma ay square. This is equal to 3028 same Q, same fourth. 3028 same fourth. Sigma Ig1 plus Ig2 plus Ig3. Clear? This is equal to 1 cent point 337 cm fourth. Right? Now from this table I will find out y bar and I. Now y bar, what y bar is equal to sigma ay by sigma summation of ay 316 by sigma 52 same q by same square. Answer is same. Clear? 6.07 cm. 6.07 cm. So I bar is equal to 6.07 cm. Now first locate the G. Clear? This is y bar. Y bar means sigma y by sigma y. So what is where is y bar? This is y bar. This is 2 cm. This is 5 cm. 7 cm. But y bar is 6.07 cm. So this is y bar. Suppose this is G. Clear? This is y bar. Y bar. Right? So now you are none. This is 1 section. This axis 1 Clear? So moment of inertia about 1 I11 is equal to sigma Ig plus sigma ay square. What is I11 is equal to sigma Ig 177.337 plus 3028. So I11. Clear? I11 is equal to 3205.33. 0.337 3205.337 cm fourth. I11. What is IXX? This IG or IXX or I. means I. What I is equal to? But I11 is equal to I11 is equal to Ixx or I plus sigma into y bar square. Sigma into y bar square. This is Ixx. What is Ixx is equal to? I11 minus sigma y bar square. This is Ixx I11 3025.337 minus sigma A. What is sigma A? 52 into y bar 6.07 square. This Ixx about G centroid. This is equal Ixx is equal to 1289 cm fourth. 1289. This is I. This is equal to I. Right? This is I y bar. Now this y bar, what y bar is equal to? Yt. This is tension side. This is compression side. So this is Yt, this is Yc. Clear? So Yt is equal to y bar. What y bar is equal to? 6.07 cm. Yc is equal to total distance 10 plus 2 plus 2, 14 minus 6.07. So Yc. What Yc is equal to? Yc is equal to 7.93 cm. I already told you in theory, but first find out y bar. Y bar means Yt, distance in tension side. Then find out Yc. Yt means above the neutral axis, above the CG. Yc. Now, for Yc and Yt, this is Yt. Take the bigger value of Yc and Yt as y. That means this is 6.07, this is 7.93. So the bigger value is 7.93. Hence, in this case, y is equal to bigger value of Yc and Yt. That is y is equal to 7.93 cm. Clear? This is y, this is I. Now find out bending stress, sigma b. Y is equal to 7.93 cm. I is equal to this 1289 cm fourth. Now the question is find out the bending stress. What is the moment? Moment m is equal to, what is m is equal to? Bending moment m is equal to 500 kg meter to 500 into 100 kg cm. Clear? So m is equal to 50000 kg cm. Right? This m I y, the sigma b. Let sigma b is equal to maximum bending stress or bending stress. Bending stress. Clear? What is bending stress? Now, from equation of bending, sigma b by y is equal to m by I is equal to E by R. Clear? Use this value. Now, sigma b by y is equal to m by I. Clear? The same place. Sigma b by, what is y? 7.93 m 50,000 I 1289 sigma b. Clear? Sigma b is equal to 307.6 kg per cm square. Clear? This answer for bending stress induced in the beam. Now, this is question number 80. This is T section. The question is, you have done two drill plugs, 150 mm and 50 mm, are connected to form a T section. Clear? If a moment of 30 km is applied around the horizontal neutral axis, inducing tension below the neutral axis, find the stresses at the extreme fiber, and also find the total tensile force on the cross section. Clear? First, this is figure T section. Now, first find out what is y bar distance of neutral axis from the extreme fiber. Find out questions. This is T section. This section 1, section 2. Section 1, 150 mm, 50 mm. Section 2 is also 150 and 50 mm. Both form a T section. Clear? Now, the question is, find the stresses at the extreme fiber, also find the total tensile force induced in the section or beam section. First, find out y bar and I. Now, dot the rule. Section area y, ay square, ig. Clear? Section area a, y, ay square, IG. Right? Now, section 1. For section 1, what is area of section 1? Suppose this is 1. Find all the figures, all the values, different axis corner. Different axis corner. Clear? For section 1, what is area? 150 to 50. Area is mm square. This mm2, mm4, mm4. Right? Section 1 per area 150 into 50 7500 m square. Clear? Why? This is G1. This is Y1. Y1. Clear? What Y1 is equal to 150 plus 25. 175. Now, AY. What AY is equal to? AY is equal to 131, 2500. 7500 into 175. 131, 2500. This is AY. AY square. AY square is equal to 2.2062. Can write. This is this. Clear? 1312500. This is equal to 1312500 into 175. AY square. Clear? This is equal to 2.296 can write. 2.296 can write. Next IG1. IG is IG1. What IG1 is equal to? BD equal to B means 150 into 52Y 12. Clear? This is answer is equal to, this answer is equal to 1562500. 1562500. This is MM4. This MM4, MM2, MM square. Let's come to section 2. Section 2. What is area? Set by 150. 150 to 50. Set by 00. M square. G2. This is G2. This is G2. Clear? This is Y2. This is Y2. What Y2 is equal to? 152, 75. Y2 is equal to 75. AY 7500 into 75. AY. What is AY is equal to? 562500. 562500. AY square. This and this. What is AY square? 562500 into 75. Clear? 562500 into 75. AY square. This is equal to 0.4 to 10 right. 0.4 to 10 over. Next, IG2. BD equal to IG2. What IG2 is equal to? B 15 to B2 152 by 12. Right? So IG2 is equal to 40 5625 4 zeros. This is section 2. Now 1 plus 2 sigma A. What sigma A? This for this 750 plus 750 15,000. 15,000. Next, sigma AY 1 by 2 by 00 plus 562500. This is equal to 1875000. 1875000. 1875000. Next, sigma AY square. This for this. Clear? Is equal to 2.71 10 by mm4. Sigma Ig. This for this is equal to 0.5781 into 10 by 8. Right? Sigma Ig, sigma Ay square, sigma Ay, sigma A. Now, now y bar. What is y bar equal to? Sigma y, sigma y. What is sigma y? 1875000 by sigma 1500 y bar. Clear? Y bar is equal to 125. So y bar by 25. Clear? What is y bar? This is 150. Clear? 125. Suppose this 75 y to 75. This is 125. This is G. Right? G means distance of G from section 1 from line 1. So this is equal to y bar. Y bar is equal to 125. Right? Now, also, below this is nuclear axis. I already told you the nuclear axis passes through the scissor figure. This is NA. This is nuclear axis NA. So, below nuclear axis tension side, above nuclear axis compression side. So, this is YC, YT. This is YC. Total depth is 150 plus 50. 200 mm. So what is YT is equal to? Y bar. Here YT is equal to here YT is equal to Y bar is equal to 120 mm. YC is equal to 200 Now we already found out YT, YC. Now we calculate I. So what is I? Now I1 is equal to, from figure, I1 is equal to sigma I plus sigma A y square. What is I1 is equal to? One index about 1 on axis. What is sigma I? 0.5781 into 8 plus this plus 2.7 into 8. Clear? So I1 is equal to 3.28 into 8. 3.28 into 8 mm. Use calculator and find all these values. Clear? This I1. But what is I1 is equal to? But I1 is equal to IXS plus sigma into y bar square. This IXS, this x-axis, this is IT, this is I1, I. Clear? Now according to correlation theorem, the moment of inertia about any axis is equal to the sum of the moment of inertia about parallel central axis IXX plus product of the total area into the square of the distance between the two axes. That is I1 is equal to IXS plus sigma into y bar square. Now put the values. What is I1? 3.288 into 8 is equal to IXX plus sigma I. What is sigma I? This sigma I 15000 into y bar square. What is y bar? 1.50 square. Clear? Now IXX. Now we find out IXX. IXX is equal to 1944 into 8 mm. Right? This is moment of inertia about x-axis. Means I, this is I. Now we have calculated three values. One, YT. Or YT is equal to, like this YT, 120 mm. YC, what YC is equal to 10 mm. I, what I is equal to 0.944 into 8. Clear? I have calculated three values. This is both. Now use these values to find other factors. Now, vice side, we'll find out sigma T and sigma C. By stresses, let sigma B equal to stress on tension side and sigma C equal to stress on compression side. Compression side. Now, from bending equation, from equation of bending, m by I is equal to sigma T by yt. Clear? Now find sigma T. Now sigma T is equal to yt into m by I or yt. M moment given bending on m is equal to given bending on m is equal to m. Clear? M is equal to 3.4 kilonewton meter. 3.4 kilonewton meter. This 3.4 into 10⁶ Newton meter. Put the value here. What am I taking? 1.5. Clear? Yt. And 3.4 into 10⁶ by I 0.944 This is mm4. This is mm. This is Newton mm. So mm cancel out. The answer is Newton per mm square. Right? What is the answer? The answer is 4.5 Newton per mm square. Sigma T is equal to 4.5 Newton per mm square. Now, sigma C. Sigma C. Stress on compression side. Similarly, m by I is equal to sigma C by yc. Then this implies sigma C is equal to yc into m by I. What is yc? Yc compression side. This yc. The yt yc. What is yc? 75 mm and 3.4 10⁶ Newton mm by I 0.944 10⁸ mm. Right? mm square. Now sigma C. Sigma C stress in compression side. This is equal to 2.7 Newton per mm square. This is stress on tension side, stress on compression side. Now the question is find the total tensile force induced in this section. Total tensile force. Now we know below neutral axis the beam subject tension. This is below neutral axis. Clear? So this area will be subject tension. Right? Again, first find out the area of this section. Then find out the average stress. We know the stress is ratio at the ST fiber and 0 at the neutral axis. So what is the average stress? 0 plus secant divided 2 into area of this section is equal to total tensile force. Clear? It is clear that the section is subjected to compression above neutral axis. Above neutral axis and tension below neutral axis. Below neutral axis. Clear? Now, so this area is subject to tension. So area under tension is equal to area under tension is equal to 50 to this or this length YT 125. Clear? 125 to 50. So this amount is equal to what is amount? This amount is equal to 6250 Clear? Now total tensile force is equal to average tensile stress into area. That is FT is equal to what is average tensile stress? 0 plus 4.52 into area 6250. This is Newton per mm square. This is mm square. The answer is Newton. The answer is in Newton. Clear? So once for 0.62.5. This will have 140.62.5 Newton. This is equal to 1.065 Newton. FT is equal to. Clear? This is total tensile force in the beam. Means that is below the neutral axis. Below the neutral axis, the beam is subject to tensile force. Above the neutral axis, the beam is subject to compression force. Clear? This is question number 80. Next, this completed problem 80. Next class I will do problem 81 and 82. Two problems I will do for this chapter. Clear? I section, B section, two problems I will do. Clear? Then complete this chapter. Then let's start. Clear? Next class I will complete chapter. Then I will start another new chapter. Either a column or torso. Clear? Thank you.